In the case of NVIDIA and co-design, we got 1 million X over 10 years. 1 million X. And so somewhere between 100,000 X and a million X. Okay, so there, when you're talking about numbers that big, it really doesn't matter. And so a million X over 10 years, we were able to get scaling and computation scales so large, so fast that AI researchers say, why don't we just take all of the internet? Why even worry about what data to go curate and what data to create? Let's just take all of the world's data and just give it to the computer.
1 million times faster, not 100 times, not 1,000 times, 1 million. That number and what caused it is why every AI company on the planet exists right now. Jensen Huang just gave a lecture at Stanford for students. First principles, no PR filter. In this breakdown, the 60-year computing reinvention, the 1,000 X calculation nobody else is covering. The moment Agentic AI changes everything about how computers work, and the billion-dollar mistake he made, and what he built from the wreckage. Plus, 5 lessons every founder needs before they run out of time to use any of this. Subscribe if you're new. This is the one. Let's get into it.
For the first time, as dramatic as it is, for the first time really in about 60 plus years. The computer that we know of, that you all use in our computing model, our mental model of a computer, the architecture of a computer, how you write the program, run the program, how you think about even taking computers to market, what it's used for 64 years, it has been largely the same since the IBM System 360. You know, one simple way to think about it is computing as we knew it before was largely pre-recorded. It's content that we pre-recorded, images, videos, you know, software that we largely pre-recorded. But now everything is generated. And the nice thing about generating everything in real time is that it could be contextually consistent, contextually relevant to what it is that you're dealing with. And of course, it can respond to your intention, not just explicitly to the things that you instruct. And today's computing is really on-demand computing. The word on-demand was actually created in our generation to talk about how you think about using computers. Time-sharing computers that you would use on demand became cloud computers. And cloud computing, of course, is on demand, but in your new world of agentic system, the computers are now continuously running.
60 years. The same computing model from the mainframe to the iPhone to the cloud. Jensen's point is not that computers got faster, they did. The point is that what a computer fundamentally is. What it does, how you build it, how you think about it. That hasn't changed since 1964 until now. The shift from pre-recorded to generated isn't a software update. It's a new operating principle. And the shift from on-demand to continuously running isn't a cloud upgrade. It's a completely different architecture question. Now, the question is, what actually made this moment possible? And this is where Jensen gives you the number nobody else is using.
Well, Moore's Law back in the old days, you guys all know about that. Moore's Law was about 2x every 18 months, so call it 10x every 5 years. Okay, so 10x every 5 years is 100x every 10 years. And that was in the good old days of Moore's Law. And for all the computer scientists in the room, you know that Moore's Law was underpinned by a concept called Dennard scaling, and Dennard scaling ran out of steam several years ago, probably about a decade ago, in fact. In the case of NVIDIA and co-design, we got 1 million X over 10 years. 1 million X. And so somewhere between 100,000 X and a million X. Okay, so there, when you're talking about numbers that big, it really doesn't matter. And so a million X over 10 years, we were able to get scaling and computation scales so large, so fast that AI researchers say, why don't we just take all of the internet? Why even worry about what data to go curate and what data to create. Let's just take all of the world's data and just give it to the computer. If you were able to travel at the speed of light, where we choose to live doesn't matter. If you were able to go from New York to California in 10 minutes, our freedom, everything about society would change, right? And so if you're able to do computing 1 million times faster, everything about computing changed. And that's really the big breakthrough.
100 times faster over 10 years. That's what Moore's law had left to give. 1 million times faster over the same 10 years. That's what co-design delivered. The gap between those two numbers is not an engineering footnote. It is the entire reason AI exists at all as a usable technology right now. Jensen's point about the internet is the most important sentence in this lecture, and almost nobody is saying it out loud. You only decide to train on all the world's data if you have the compute to process all the world's data. At 100x faster, you still have to be selective. At 1000x faster, you stop selecting. You just take everything. GPT didn't happen because someone had a clever idea. It happened because someone had enough compute to feed it the whole internet. Jensen built that compute. That's what NVIDIA is.
And so what happens in a world where the computers are continuously running? What happens to cloud services? What happened to your personal computer? What happens to, all of these different systems? Now there's a great opportunity again to rethink all of that. A couple of years ago was in the generative part of AI. And as you guys know, generative AI not only made it cool for us to do image generation and text summarization and translation and whatnot, but generative AI also enabled us to think. And so when I saw generative AI, what other people saw was that it was able to generate images, and I surely would appreciated that as well. But the fact that you can generate thoughts in the form of images, but you can generate thoughts, you can also reason with it. And the ability for AI to think after GPT was very, very obvious. It's not possible for universities, for pre-recorded textbooks to keep up with information and knowledge that's being generated in real time by AI. And so I think the future probably has to be some union of the two. And I don't know about you guys, but I can't learn anymore without AI. And so not only do I have the AI read the papers, but I also have, once it reads the papers, I might ask it to go read a whole bunch of the other papers that are associated with it. And then now it becomes a super researcher. And then I can first I ask it to summarize, I ask it some basic questions. And then after that, you interact with that paper as if it's a researcher that's dedicated to you.
Jensen just described the next shift as clearly as anyone has. On-demand computing, you ask a computer something, it responds, you move on. That was the mental model for 60 years. Cloud is just on-demand computing at scale. You request a resource, it runs, you close it. Agentic computing is different. The computer doesn't wait for your request. It is always running, working, reasoning, generating in parallel on your behalf in the background without being asked. And Jensen saying, I can't learn anymore without AI, that's not a founder in a LinkedIn post. That's the architect of the compute layer describing how his own cognition has changed. If you found that useful, like the video. It helps this reach more people who need to hear it.
The mistake that I made, that I would say was a genuinely straight up mistake, is when the PC or when mobile devices took off, we were approached by very important companies that are important in the mobile space to work on some mobile devices, and the choices that I made. I think the answer, when they approached us, the answer should have been, nah, not interested. But we decided to shift a bunch of our resources to go build mobile devices. And I thought that we could add a lot of value, but it turned, I think if I would have thought through it a couple more clicks, the amount of value you can really deliver for the things that we know how to do and what we're good at is probably marginal at best. It grew into $1 billion business, and that kind of positive reinforcement. And then shortly after, during the 3G to 4G transition, we were just 100% locked out. And Qualcomm was the leader in that 3G to 4G modem, and that's the most important part of the phone, not the SoC, not computer graphics, not even the application processor. The phone is obviously the most important part. And so during that transition, they were able to block us out. The recovery was I took all of that expertise, that extreme low power and energy efficiency expertise, and I shifted all to an application that didn't exist at the time called robotics. And so all of somebody mentioned Thor. Thor is the great grandson of the chip that we were using in mobile devices. And that entire genealogy and all the teams and all the expertise that we built up was really helpful to getting here. And so that's rationalization. Going into that market in the first place was a waste of time. And so that I think is a strategic mistake.
$1 billion built in 2 years, gone to zero in the transition to 4G. Jensen's own verdict, going into that market in the first place was a waste of time. But the recovery is the part that matters for every founder watching this. He didn't write off the investment, he took the teams, the expertise, the low power chip design, knowledge, and he moved it to an application that didn't even exist yet. Thor, the chip inside today's NVIDIA Robotics platform, is the direct descendant of the mobile work that went to zero. The lesson isn't don't enter mobile. The lesson is when a market shuts you out, the expertise doesn't disappear. You just have to find the next application for it. That is what Jensen means when he talks about strategy.
The first thing I do is what am I observing? What am I observing? And based on what I observe, let's reason about it back to first principles, break it all back down, and ask ourselves, so what's going to happen next? And first, so what? Is this a big deal? Hey, deep learning, computer vision, AlexNet, big deal. Is that a big deal or not a big deal? And so the big deal part of it is, my goodness, in just one, here's two engineers, right? Alex and Ilya, and Hinton, of course, and they came up with a neural network model, and boom, it crushed the computer vision capabilities of all the computer scientists, decades before them. The skill of building companies, then, of being successful along the way, is you're going into this direction, and it's going to take energy, it's going to take time, it's going to take money, and everything that time, energy, and money, that takes away from something else, right? So the cost, the opportunity cost of pursuing a strategy is the real cost. And so you just got to ask yourself, how can you be smart enough such that the opportunity cost is reduced and your optionality is increased?
Jensen Huang just gave us the cleanest version of the AI thesis I've heard from anyone. Not AI is changing everything. We've heard that. Not you need to adapt. We've heard that too. This. Computing is being reinvented for the first time in 60 years, driven by a 1,000x improvement in capability. That improvement crossed a threshold where you could train on everything, not just selected data. That produced reasoning. Reasoning produced agents. Agents that run continuously will change every system you currently think about as computing. That's the architecture of the moment. And this lesson from the mobile mistake is the most important strategic warning for any founder right now. The opportunity cost of pursuing the wrong direction is the real cost, not the money you spent, the time you didn't spend going somewhere else. 5 lessons. Let's go. Lesson 1. Run the "is this a big deal" test on every AI tool you encounter. Jensen's framework starts with one question: is this a big deal or not? Most founders are drowning in AI noise because they skip this step. Take one capability you've been ignoring and run the test properly. If it crushed the previous approach in one shot, that's your AlexNet moment. That's your signal. Lesson 2. Calculate your own 1000x question. Jensen didn't get there by improving one thing. He co-designed across every layer simultaneously. Chips, networking, software, frameworks. The question for your business: where are you optimizing layers in isolation that could be solved together? The step-change improvement is almost always hiding in the gap between the layers. Lesson 3. Don't write off the wrong market. Extract the expertise. Jensen lost $1 billion in mobile. He recovered not because he had a brilliant new idea, but because he moved the people and the expertise to the next application. What does your team know from something that failed or stalled that maps to a problem AI just made possible? That's your Thor chip sitting in a graveyard. Lesson 4. Treat your stack like an agentic system, not a set of on-demand tools. Most founders use AI on demand. Open it, get an answer, close it. Agentic means it runs in the background all the time, monitoring, preparing, reasoning, flagging. This week, find one process that currently needs you to kick it off. That's your first agentic opportunity. Build it before your competitor does.
Lesson 5. Manage opportunity cost, not just spend. The opportunity cost of pursuing a strategy is the real cost, not the money, the time. Every week on the wrong direction is a week you handed to whoever is going the right way. The question isn't, can we afford this? It's, what aren't we doing because we're doing this?
If this has been useful, like the video, subscribe if you haven't already, and drop a comment below. Which of these 5 lessons applies most to where you are right now? See you on the next one.